Hello my dear students, hope so doing good. Today we are going to learn the Gauss's law applications. For that we can calculate the electric field. Okay, so first let's understand what is the continuous charge distribution. So students, here you can see that what is the continuous charge distribution, because we can deal with the charges in two ways. One is the microscopic way, another one is the macroscopic way. So first understand this. So see please, at microscopic level, charge on any charged body can be calculated by using Q equal to plus minus Ne. But this is not the practical way. Then what is the practical way? See please, at a microscopic level, continuous charge distribution on any charged body is calculated by using the charge density concept. And according to it, there are how many kinds of charge densities? There are three types of charge densities are there that we are going to see the next one. So see please students, linear charge density. What is this? It is defined as charge per unit length of the body. Okay, so lambda is given by Q by L, where Q is the charge on the body, L is the length of the body. So lambda equal to Q by L. Similarly, next one, surface charge density. What is this? It is defined as charge per unit area of the body. Per unit area. That means here we will write here sigma. Sigma equal to Q by A. You can write Q by S also, no problem. Okay. Last one, volume charge density. What is this? It is defined as charge per unit volume of the body. Okay. And this one is represented by rho. And we will write here rho equal to Q by V. So depending upon the situation, we are dealing with the length, area or volume, we have to use one of the charge densities. Okay. Next one, students, we are going to see some cases of electric field by Gauss law. So first one, what is this? EFI, that means electric field intensity due to uniformly charged solid or hollow conducting sphere. So here I have taken conducting sphere, and you know very well the charge will be always where? It will be always on the surface, uniformly charged. No? So here I have taken uniformly charged, positive. By default we will take positive. Sometimes in the question they can give negative also, but most of the time it will be positive only. So first one, what we are going to see please, let charge Q is uniformly distributed on a spherical conducting sphere of radius R. So here this radius, how much here? The radius is R and the charge is Q. Okay. After that, what will happen at here? Outside, if we want to calculate the charge outside, then what we have to do? We have to take the observation point. Let's take this is my observation point outside. I have taken observation point A. This distance, how much here? Center to observation point is always which one? Is small r. So remember that whenever the observation point is outside, what will happen? The total charge on the conducting sphere can be concentrated at the center. So when the charge will come on the center, that means then electric field intensity is given by 1 by 4 pi epsilon naught into Q by R square. Okay, very simple. Next one, if we see here, at the surface or just outside. So here please, here again, this is the radius R and here charge Q is there. As I told you, charge is the distributor. So now what is there? We have the observation point is where? Just at the surface, and this distance how much? This distance R. So here we can write here just outside or at the surface, this R will be approximately R only, is it? So in this situation, electric field is given by, just let me correct it. Here also, here one more thing is there, I have this here, see, this R should be greater than R here, okay? Next one please here. So here, this E surface is given by, again, 1 by 4 pi epsilon naught into Q by R square is there. This is where? At the surface. Now, after that, inside. Inside means where? Again here. Let me draw here. No, we'll draw here. And let's take now what is there. I have taken the observation point is where? Inside. Okay. So here what will happen that here through the observation point, we will imagine one Gaussian surface here. And let's take, for example, some electric field is there, and we know electric field is always away from the positive charge. So here I will take here one Gaussian surface. Electric field is this side, and Gaussian surface is also this side? This side here. Okay. So what will happen that here, according to the Gauss law, we know very well, closed integration E dot ds is equal to charge enclosed by how much? R square. Now, after that, if in case any kind of electric field is there, so at all the points of Gaussian surface, this will be constant, so E will come outside and close integration of df. And here what will happen that here? One mistake happened here. What mistake happened? According to Gauss law, here we have to correct it. This should be Q enclosed by epsilon naught. Okay. So can you see any charge inside this Gaussian surface? No, there is no charge inside this Gaussian surface. So what will happen that here? It will be 0 by epsilon naught. So even when you will simplify this here, this E will come how much here? 0. That means inside the sphere what will happen? Electric field will be how much? 0. Okay. So here I have taken which one? Hollow conducting sphere. Even in case solid conducting sphere is there, in that situation also the charge will come where? On the surface. Okay. So you can see here, as we have written the formula. What was the formula was there? E out, the formula was K into Q by R square. E surface, what is the formula? K into Q by capital R square, and E inside, how much is there? 0. So if in case I will just draw here the electric field line here. So see this like this. No? Let me draw here. No, like this. This side R is there, and this side what is present? E is present here. No? And anyhow this radius is R. So what will happen that here? This is the center. Here small r equal to capital R. And this side is small r equal to minus r. So can you guess please which kind of graph will come here? Inside there is no electric field here. Okay, so just dotted line here, and this is the surface. So the graph will go like this here. Okay, and here what will be there? This E out will be inversely proportional to r square. This is the graph electric field due to which sphere? Conducting sphere. Next one after this, students, here please, electric field intensity due to uniformly charged solid non-conducting sphere. In case of solid non-conducting sphere, what will be there? The charge will be uniformly distributed inside non-conducting sphere. So in this situation also, what will happen that if in case I want to calculate the electric field where outside. So outside how much here? You know very well, R greater than R. And in this situation, electric field outside will be how much here? Same story. 1 by 4 pi epsilon naught into Q by R square. Why? Because the total charge again can be concentrated where? At the center. So like this, if I write here, now this is point A is there. This is R. Radius is capital R. And here charge Q is there. Total charge will come where? At the center here. And at the surface, same story, small r equal to capital R. So in this situation, what will happen that here? At the surface, here also same story, 1 by 4 pi epsilon naught Q by R square. Okay, and this is pi. Okay, so what we can see, due to the conducting and non-conducting sphere on the surface and outside, the charge or what we can tell electric field value is what? Same. Next one, students, you can see here, we are going to calculate the inside. Here this is somewhat interesting. Why? Because see here I have taken the charge. No? The charge is distributed all around it inside. No? So now what will happen that here, if I take here one point here, no? Point C I have taken, no? And this is my center O. This distance how much here? Is small r. So through this point C I will take here one Gaussian surface. So this time you can see that inside the Gaussian surface some charge will be there, and this charge will be how much here? Q enclosed. Here we have to use volume charge density. Why? Because charge is where? Inside the body, inside the sphere. So Q enclosed is given by what? Rho by 4 by 3 pi r cube into 4 by 3 pi small r cube. And what this will come here? Rho small r cube by capital R cube here. Na? And what is capital R? Capital R is the radius of the sphere. After that, what we'll do here? We will just use the same, the Gauss law. So what is the Gauss law? As we know very well, closed integration E dot ds is equal to charge enclosed by epsilon naught. So again, what we can tell, at all the points of the Gaussian surface, this Gaussian surface should be symmetrical Gaussian surface. So what will happen? At all the points, the charge will be same, electric field will be same actually. No? So what will happen that here? This is the electric field and this is the ds value, and E and ds is making how much angle? 0 degree here. So E dot ds means E ds cos 0. Electric field at all the points are same. So we can write here E integration of ds, and charge enclosed how much? What we have got here? Rho small r cube by capital R cube, and here epsilon naught. So E, what is the surface integral? We can write here 4 pi r square is rho r cube by capital R cube into epsilon naught is there. Okay, students. So I hope so we are going very correct. So if in case we will simplify this E value will come rho r by 3 epsilon naught. This value should come here. Now just check out please. This 4 pi is there or not? Rho r by 3 epsilon naught should come here. Okay, And here what will happen that here this electric field will be anyhow directly proportional to R. I will just check one time. Okay, you just check it little bit here, little bit calculation is there, you just check it, no problem here. Okay. Next one, what will happen that here, if we draw here the graph, E versus R graph, okay. So what I have told you, E out will be K into Q by R square, this is E out, E surface how much here, it is again K into Q by capital R square, and here E inside, as I have told you, it should come rho R by 3 epsilon naught, okay. So what will happen that here, we have to just draw here the graph, no? So again, this is R, this is E, and the radius how much, the radius is here, no? Radius is here capital R, charge is everywhere distributed. So what will happen that here in this situation, from center to surface, the charge will increase directly proportional here, no? Like this here, and after that what will happen that here, it will go like this.